Okay, I want you to take a look at this right here. Now, we're into graphing and shading. All right. Now, we know how to graph and shade a line. So you should know how to graph and shade what? Two lines. All right, is everybody with me on this? All right. So a lot of times on multiple choice tests and on the SAT, they give you the graphs and you just have to figure it out. All right. So this should help you with that. All right. So here, I want everyone to make a note to themselves. I'm shading what? Above or below? One of them's below and one of them is what? Above. Now, I would like everyone to look at number two, this one right here. Right? This one, this is the area that's been shaded that is the intersection of both. All right, let me give you an example. I'm stuttering a little bit. So if I graph this line and I want to do greater than, right? Does everybody agree it would be this way? Right. Then I'm going to graph the other line and it would look something like this. And I'm going to shade, let's say, less than. It would be this way. Do we agree? So then where they intersect are the solutions. So all of this over here would actually be the answer. Is everybody with me? Right? So now in example 2 right here, you're supposed to look at that and say, well, that's shaded less than and less than. Do we agree? But one of our answers is less than, and the other one is what? So it's not that one. Just like on number 3, this shaded area right here would be what? Greater than and greater than. Does everybody understand this? Right? This area right here would be greater than and greater than. Do we agree? So it's not this one either. So it's either got to be 1 or 2 because one's greater than and the other one is what? Less than. All right. So now we have to just determine what goes where. All right. So please, here we go and hear me out. All right. I'm going to first graph this guy right here. I'm going to go up 3. So I'm going to start with graph number 1. I'm going to go up 3 and plot a point. And then from there, I'm going to go what? Up 1 and over 1. So if I go up 1 and over 1, do I agree that's part of the line? I draw the line. And now I'm supposed to be shading what? Below. So that's not the answer. So the answer must be what now? The answer must be 3. All right, now the reason why there's so many papers here is because I wanted to make sure you were good with this. All right. So if you'll see, there's like one problem on each page. There's really not a lot of information there. All right. So it's just the only way to do it was to make, I didn't want to make it so small you couldn't see it. All right. So here we go. Let's look at question number 2. Now I have a little problem with number 2 because the X is in the wrong spot. Do we agree with that? So I'd like everybody to convert that. Now look, if you don't know the conversion, look, I mean, you're like 6 months behind us. I need to move the X over. If I move the X over, it becomes what? Negative X. So everybody should be looking at that saying Y is greater than negative X plus 2. And the other one is Y is less than or equal to 3X minus 2. Now, how do I automatically know it's not number 1? Because, say it, there's not a dotted line. There's not a dotted line. So it can't be number 1 or what? Or what? 3 over here. All right. Now, once again, some of you, I feel like just sit here because you don't know it. You're afraid to say, man, help me. Instead of, I'm sorry, I'm a little behind. Be patient with me. Can you please help me out and get me out of this hole? But some of you prefer to be in the hole and never climb out for some strange reason. Anybody have a problem with that? Anybody not know why I crossed out number 1 and number 3? Because there's no line underneath the first one. So that means this line had to be a dotted line. One of them has to be a dotted line. Do you understand this now? You sure? All right. So for question number 1, there is no dotted line. Neither one of those is dotted. Neither one of these is dotted. Therefore, it can't be this one or this one. One of them has to be dotted. One of them has to be dotted. Is that making sense to you now? Maggie? Because they're both equal to. They both have to be solid dots, solid lines. Solid lines. What? What do you think? Less than. Below. Doesn't that make sense, right? I want that to be obvious. If you're shading less than, you want to be below. Greater than is above. All right, come on now. Now, do we agree that I have to go up to? So I'm going to try to graph this one right here. I'm going to go up to, plot a point. From there, I'm going to go what? Come on. Down 1 to the right 1. Down 1 to the right 1. Does that look good so far? Yes. Is it a dotted line or a solid line? Dotted line. I'm shading where? Above or below? Above. So if I shade above, is that going to be correct so far? Yeah, it looks good to me. That's probably the right answer, because if I come over here to number 3, they're shading it what? Below. So is it number 4? No, this was the correct answer. All right, here we go for the next one. Now, I'd like everyone to highlight what the answer is for number 3. Highlight what the solution is for number 3. Darken it in so you know. And some of you are like, I don't know what you're talking about. All right. So here is the answer that I want everyone to say. This right here is the solution. Is everybody okay? It's where the lines overlap. That's the answer. Anybody else having trouble with that? All right, if it's not in that green area, it's not an answer. So is 7-0 an answer? Well, I don't know how some of you jumped at that so fast, but I'm assuming you're correct. So I'm going to take my dot here and I'm going to plot the point 7-0. Here we go. 1, 2, 3, 4, 5, 6, 7. Is that an answer? Why would you say no? Right? Is that an answer? Yeah, because it's in the what? It's in the green area. So that is a solution. And like I said, I'm okay because I didn't understand. People didn't know what I was saying. I just thought this was obvious. That's why I did this whole thing, because last year it wasn't obvious to the kids. Now, is 0, 7? Well, 0, 1, 2, 3, 4, 5, 6, 7 is way up here. Is that in the green? No. 3, 0. Wow. Now that one's a nice one. So would you say yes or no? What if I told you would be correct if this was a solid line? Is that a solid line? No. You with me? Everybody agree? So that was a very hard one. It's on the dotted line, correct? Does the dotted line count? No. If you're on the dotted line, that's not a solution. If you're on the dotted line, it's not a solution. So 3, 0 is not an answer. Now, everybody do negative 3, 5. And obviously, that's what? Yeah, obviously not. All right. Now, over here, the problem I did was I just didn't draw the graphs for you. Right? I didn't draw the graphs. And because I didn't draw the graphs, your job is to now just plug 5 in for what? And 3 in for what? That's what you have to do. So I'm going to plug for X and Y right here. So I'm going to come over here and say, what's the Y value? What's the Y value? 3 greater than negative 1/2 times 5 plus 5. Now, for those of you guys who can't do math very well, take out your calculator, all right? Or the rest of us can say half of 5 is what? 2.5, but it's what? Negative. So 3 is greater than negative 2.5 plus 5. What's negative 2.5 plus 5? Is 3 greater than 2.5? Yes. So far, that's an answer. It works for the first one, but it also must work for the what? For the second equation. So now I plug in the second equation. Just let me get through. I plug in for the second equation. What was the Y value? 3. Is that less than or equal to 3 times, what's the X? 5 minus 2. Is 3 less than or equal to, what's 3 times 5? 15 minus 2. Is 3 less than or equal to 13? You guys are so, like, I'm asking the question, is 3 less than 13? Nope, couldn't possibly be true. Is 3 less than 13? Yes. So was it true on the second equation? Therefore, is it an answer? If it's true for both, then it's an answer. You're right. It does. Thank you. I'm not reading. Thank you. So that is a solution, but it's not the what? It's not the answer. Thank you. And again, I hate these problems. All right. So it says which one is not? Which one is not the right one? All right. So is everybody okay with that? All right. Make sure you're understanding me because I just messed that up. All right. One would be an answer, but because it's an answer, it's not the solution. All right. So now let's try number 2. Let's plug in 4 and 3. All right. If I plug in 4 and 3, 3 is greater than negative 1/2 times 4 plus 5. 3 is greater than negative 2 plus 5. Is 3 greater than 3? No. Is 3 greater than 3? So is that a solution? No, but we're looking for the one that's what? Not the solution. So that is the what? So that's the answer. All right. And these are the types of things that I'm telling you for those of you guys who are going to take these HSPT tests or whatever coming up this weekend. These are the details you got to be careful with. All right. Please be careful with the details. All right. Does everybody agree that would be the answer then? All right. That would be the answer. Annoying. All right. Now, for me right here on the next one, I'm going to work it with you. Does everybody agree I can just divide everything by 2? Make it a little bit easier, right? So the first equation would be y is less than negative 6x plus 2. Do we agree with that? Now, this one is just which point is a solution. So let's try 1 and 1/2. If I plug 1 in for x and 1/2 in for y, I get 1/2 is less than -6 plus 2. 1/2 is less than -4. Is that true?
Yes. No.
Is 1/2 less than a negative? No. So is 1 the answer? As soon as it doesn't work, then we can move on. Do we agree? Right now, this is where some of you, I'm sitting here doing the work and I'm relaying numbers to you, and you're just like, man, he's good at this. You're the one who's supposed to be saying yes or no. If I say, what's -6 times 1, you're supposed to say -6. You're supposed to be doing your own calculations here. You can see for yourself. That's what I'm trying to show some of you. We got 6 months together still. I can still make you better, but you got to want to work. That's what the issue is. Good for you, Leah. What? Where did the 1 go? I plugged 1 in for X, kiddo. You see it? All right. Now I'm going to plug number 2 in. All right. So what's the X value? 0. What's the Y value? 6. So now 6 less than, what's -6 times 0? 0. 0 plus 2 is 6 less than 2. So good. I'm crossing out number 2. Now, would I prefer to do 3 or 4? 4, because there's no fractions. So everybody, let's do 4. Hopefully, we can see quickly what the answer is. So I plug -3 in for X and 2 in for Y. So I end up with 2 is less than -6 times -3 plus 2 is 2 less than 20. So far, so good. Does that mean it's the answer? No, because I got to try the other line. So now what's Y again? Here's the second line. 2 is less than
-6x times
-6,
6x times -3.
and then plus 4 is 2 less than 22. So is that the answer? Right, that's the answer. Okay. What?
Wait, but they're both less than.
So that makes it an answer. Shh. That makes it an answer. Has to be true for both of them. 2 is less than 22 and 2 was less than 20.
Yeah, so why did we choose that 4?
Well, because I didn't feel like doing a fraction. I could have chose this, right, and plugged in. You with me? But I knew it had to be either 3 or 4, right? And I just guessed 4 was easier. If 4 wasn't the answer, then I knew 3 was the answer. Agreed? All right, so now let's see what I said up here on number 6. First, consider the system of equations, -1/2 x plus 1 and x minus 5. Then consider the inequalities. When comparing the number of solutions in each of these systems, which statement is true? Now, please look, every year they ask these on the tricky questions. So are these lines parallel? No, they're not parallel because the slopes are not the same. And if you didn't know that, you need to write that down. Those lines are not parallel because the slopes are not the same. And some of you are like, well, how do I know what the slope is? All right, the slope is the number in front of the x. Are the slopes the same? No. Therefore, if the slopes are not the same, there is one solution. There is one solution. Everybody good with that? Now, for the inequality, greater than and less than. So if I were graphing this, come on, everybody can look, watch me graph. 1/2 plus 1 would look something like this. And then it was shaded above, correct? And then the other one would be x minus 5, and that would be shaded below. How many solutions on that? How many solutions? Definitely not one. How many solutions here? Anybody?
4.
Why do you think 4?
Well, because 1, 2, 3, 4.
All right, so let me show you this, please. Look up. I'm going to take this point right here. Is that a solution? Is that a solution?
Yeah.
Is that a solution? Is that a solution? Is that a solution? How many solutions? Infinite. For those of you who said 5, yeah, they're 5 because I marked 5. But now how many? Yeah, there's an infinite number of solutions. There's an infinite number of points in that shaded region. Do we agree with this? Right? So the system of inequalities has an infinite number of solutions. So the system of inequalities has more solutions, right? Now again, that's probably not going to be on the test, but I'm trying to just get you to understand. Tell me. Yes. I did say that for the equations. I said that. For the equations, these are systems of inequalities, meaning there's going to be shading involved. Come on, you're a thinker, right? So that you understand me now, correct? All of the pink area is a solution for inequalities. You with me now, right? All right, good for you, Leah. Tell me.
There's infinity, like,
Infinite number of solutions. Let me ask you this, something. You're thinking good, girl. But listen to me. If I'm going to draw something up here and you tell me if you understand me, right? I'm going to draw this line and I'm going to say this right here and this right here. How many points are in between here? The points are infinitely small, right? So if I said to you, how many numbers are there between, let's say, -2 and -3? How many numbers are between -2 and -3? You're right, infinite. You with me? So like, for example, -2.5, -2.51, -2.52, -2.523. You see what I'm saying? There's an infinite. You're only looking at whole numbers. That's where the problem comes in. You with me on that? You're right. Eventually, right? You think it's all all the points will be counted, but that's not true. Okay? All right, that was a good question. All right, here we go now. All right, now we're going to have to graph some. All right. So let's everybody take a look here. All right, what do I have to do for this -2? Divide by -2. If I divide by -2, what happens to the inequality sign? Changes. So I need everybody to put y is greater than -3/2 x minus 6. I did divide it by -2, didn't I? Now, once again, if you're sitting there going, man, please tell me what you're doing. I can't tell you if you don't ask. So everybody agree, I just divided everything by -2. When you divide an inequality by -2, you change the signs. Everybody agreeing with me? Now we have to graph this. So what do I do to graph this? Go down to 6. 1, 2, 3, 4, 5, 6. Plot a point. From there, I go what? Down 3, over 2, plotting a point. Now I'm running out of space, so I'm just going to go up 3 and left 2. Up 3, left 2. Up 3, left 2, just to exaggerate. Now, is it a solid or is it a dotted? It's a dotted line. That is correct. So make yourself a nice little dotted line there. And now we're going to shade which direction? Say it again, please. I'm going to shade where? Is it, I don't want right or left. I want above or below. Above, right? We're shading above, right? So you don't have to scribble, just lightly. Come on, I'm not into coloring. All right. Now, I need help. X greater than or equal to -3. Is it solid or dotted? Solid. At what X value?
Negative.
So at -3, we go to -3. What kind of line?
Zero.
Is it a vertical or horizontal? Vertical. So everybody's going vertical at -3. Shaded which direction?
Right.
To the right. To the right is positive. I mean, is greater than. So highlight greater than. And then the answer is where they what? Yeah, the answer is where they overlap. So where do they overlap?
Negative.
It's going to overlap right here. That's the overlapping part. Everybody with me on that? Now, Allison thinks 2, -9 is a solution. So everybody go to 2 and then -9 on your graph. I'm not sure because I haven't counted it out yet. 2, 1, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9. Is that an answer?
No.
No, because it's what? It's dotted. Right. Come on, guys. I just don't think that's hard. All right. You can graph and you can color, then you can do this. All right. Anybody have any problems with that? All right. So definitely put no. All right. You don't need an explanation. Go. Come on. Did you plot 2, -9? Did you see it? When I plotted it, it's right there on that line. Is on the line part of the solution? No, it's not. If it was a solid line, it would be a solution. All right, dotted line. It's everything up to, but not including that. All right, let's try the next one. Is 0, 4 a solution? Plot 0, 4.
Yes.
Okay, well, I don't know how you're having trouble with this, but
No.
0, 1, 2, 3, 4. Is it a solution or not? No, it's not a solution because this is the overlapping area. The overlapping area is the solution. The overlapping area is a solution. Now, if you're just putting down yes or no, once again, I'm trying to tell you it's not helpful. If you thought it was yes, be bold. Yeah, that's a solution. Some people thought yes because they realized or they looked at it and said what? It's shaded, therefore it's a solution. Is that necessarily true? No. That is not a solution. No. Number 9, here we go. Let's practice our graphing. All right, what do I have to do for the first one? Add 9. So 3y is less than or equal to, help me. Yes, I'm aware of 9 plus 12. I was hoping you would know it was 21. Break out the calculator, Caroline. So y is less than or equal to 7. 9 plus 12 today is 21. That's why we use calculators in here. All right, so here we're graphing less than or equal to 7. So how do I graph y is less than or equal to 7?
It's horizontal.
Horizontal line, wow. 1, 2, 3, 4, 5, 6, 7. We draw horizontal. Is it solid or dotted?
Solid.
Dotted.
It's
It's dotted.
It's
It's
solid.
Oh, I was on.
There's a
the
sign and there's a
I
line
was on the
below.
next one.
Thank you, Colton.
It's less than
Colton, we got you now. Enough. Less than or equal to 7 is definitely shaded below. All right, so now take your little coloring book. All right, and let's do some more coloring. All right, we're shading below. I know some of you are like so excited to get to color today. All right. Now, do I have to do anything to the second graph? No. I'm going to go where though? Down 4. 1, 2, 3, 4. Plot a point. Down 2 to the right 1. Down 2 to the right 1. Or I could go up 2 left 1. Up 2 left 1. What kind of line am I drawing now? Dotted line. And now, which direction am I shading? Where am I shading again?
The left bottom.
It's not left or right, but am I going below? Yeah, below. So now I'm going to shade below. All right, so now you need to darken in where it's the right answer. All right. So now give me a point that is a solution. Give me a point that is a solution, Colton.
-3, 0.
-3, 0. Let me check and see if you are correct. Let me have a heart attack. -3, 0. 1, 2, 3. Wow. You're alive, Colton. Very good, buddy. Very, very good. -3, 0 is a solution. Give me another solution. Go ahead, Peter. Shh. -9, -1, -3, 4, 5, 6, 7, 8, 9. Did you say -1? Yes, that is correct. All you have to do is give me a point that's in the dark region. I don't want your point. No, no. What? 0, 0, -4 is definitely not an answer. 4, -0, brilliant.
I drew a sad face because we have to work.
All right, here we go. Number 10. Here we go.
Not the last one.
Now, for question number 10. All right, I've got problems with the second equation. So for the second equation, let's try to figure that out. What do I need to do first? Subtract 3x. So I end up with -2y greater than -3x plus 4.
So close.
And now what?
Now it's
Divide by -2. Thank you. Come on, Maggie, we're working and you're playing again. No, stop telling me that. 3/2x, then what?
negative -2.
-2. There we have it. All right. So here we go. I'm graphing the first equation right here. Liv, how do I graph that quickly? 1, 2, 3, 4, 5. Then what? Brilliant. Solid line. Thank you very much. And then once we know it's solid, we're going to shade in which direction? Below. Thank you very much. So we're shading below. All right, Leah, you get to graph the other one. Okay, I'm listening. Shh, shh. Which one, kiddo? We're graphing the top one first. Leah, come on. What? Tell me, are you graphing? I know. So tell me, what did you do to graph -3/4 x plus 5? Where is the next? Are you on question number 10? You understand what we're doing now? All right. So now I'm graphing the second equation. So to graph the second equation, what do I need to do? Go to -2. Brilliant. Up 3 to the right 2. What kind of line? So here we go. And then we're shading which direction? Shading where? Below. So below is, hold up. Below is this guy. Is 6-3 a solution?
Yes, it is.
It's enough.
Where is 6-3, Bruin? 1, 2, 3, 4, 5, 6. 1, 2, 3, right?
What?
Is that a solution?
Yes. It's in the shaded part.
This is the shaded part, Bruin. It's supposed to be homework, yes,
What?
but we'll wait till Monday.
There's no one.